students, today we are going to discuss atmospheric refraction. So what is refraction? As we have seen, when the light goes from rarer to denser medium, it bends towards normal. Due to that, angle I is greater than angle R. Angle I, angle of incidence; angle R, angle of refraction. When the light goes from denser to rarer, it bends away from the normal. So in that case, angle I is less than angle R. Such a bending of light, when it goes from one medium to another, having different refractive index, is called as refraction. Now let us see what is atmospheric refraction. Atmospheric refraction. Earth, as we know, it is surrounded by its atmosphere, and the Earth atmosphere is having different layers of air. The layer which is very close to Earth, it is denser. The density of that layer is greater as compared to the density of the layer which is above it. That means as we go above, the density of air decreases. The layer which is closer to the Earth's surface, its density is greater. Then the density reduces, again reduces. Thus, each layer is having different density. If the density of air is greater, then it is denser medium. Its refractive index is greater. And if density of air is less, then it is rarer medium. That means its refractive index is less. When the sunlight passes through different layers of the atmosphere, it continuously goes from rarer to denser. And as you know, when the light goes from rarer to denser, it bends. So, bending of sunlight or bending of light, when it goes from different layers of the atmosphere, is known as atmospheric refraction. What is atmospheric refraction? When the light goes from different layers of the atmosphere, due to different density of air, it bends, and this bending of light is known as atmospheric refraction. The refraction of light which occurs in atmosphere is known as atmospheric refraction. Due to this atmospheric refraction, we observe some optical phenomena. So let us discuss the first optical phenomena, which is called apparent random weaving. What is apparent random weaving means? When you look above the fire surface, you can see the waves of air. That is called apparent random weaving, or flickering of objects seen through turbulent stream of hot air rising above fire. Flickering of object means fluctuating the position of object at which you are looking through the hot air above the fire. That is known as flickering of objects. So let us discuss this with a simple diagram. Here, let us consider we are having a fire here, and above the fire, as you know, the air will be hot. Hot air will be there, and above that, at far away distance, we are having cold air. Hot air, it is having less refractive index. Less refractive index means it is rarer. And the cold air which is above, it is having higher refractive index. That means it is colder. Colder air is having higher refractive index and it is known as denser. When the light passes through these two different media, then refraction of light occurs. And due to that refraction, we see air wave-like structure above the fire. Or during summer days, we can see these waves of air above the tar road also, because the road becomes too much hot during the summer days. Or the position of the object which you are looking at through the fire, through the hot air, it appears to fluctuate. Fluctuate means changing its position. So that is called flickering of objects. So this is one optical phenomenon, apparent random wavering of objects. Twinkling of stars also occurs due to atmospheric refraction. What is twinkling? Twinkling means sometimes the star appear brighter. Sometimes star appear brighter and sometime fainter, and sometime it appear fainter. That effect is called twinkling. Twinkling of star means sometimes the star appears brighter to us and sometimes it appears fainter to us. That is called twinkling of star. When the starlight from the star enters into the earth atmosphere, as we know the atmosphere of earth is having different densities. So continuously the starlight is coming from rarer to denser medium. Continuously the starlight is going from rarer to denser medium when it comes from star and reaches up to our eye. And as you know, rarer to denser means it always bends towards normal. So let us see through this diagram. Here we have drawn the star, actual star. The actual starlight is coming from the star and entering into the atmosphere. And in the atmosphere, the layers of the air, they are from rarer to denser. Rarer to denser, so the light always bends towards normal. It bends always towards normal due to different layers. And we are watching from the earth's surface. So the apparent position of star is appearing somewhat higher than the actual position of the star. Apparent position of the star means the appearing position of the star. It is somewhat higher than the actual position of the star. The physical condition of the atmosphere are not always stationary. They keeps on changing. So as the physical conditions of the atmosphere are changing, the apparent position of the star is also not stationary. It is also not stationary. It also changes slightly. The stars, as we know, they are very far away. So they are point size object. Point size means very small. The object which is very far away from us, it appears very small to us. So the starlight which is entering into the earth atmosphere, it varies its path, it changes its path slightly, and due to that the starlight, the amount of starlight which is entering in our eye fluctuates, and due to that sometime the star appear brighter and sometime the star appear fainter. And this is known as twinkling of star. This is very important question for your board exam. Explain twinkling of stars. So you have to explain like this with a diagram. Apparent position means, apparent star means the star which is appearing to us, and this is actual position of the star. Let us discuss one question. Why don't the planets twinkle? the star twinkles, but the planet do not twinkle. As we know, planets are closer to the earth. Planets are closer to the earth, so they are extended source. Extended source means a big source in size. As compared to stars. Planets are closer to the earth, so they are extended source or they are large in size. So they are considered as collection of large number of point-sized sources. Advanced sunrise and delayed sunset. What is sunrise? When the sun actually crosses the horizon, it is called as sunrise. But we can see the sun 2 minutes before actually it crosses the horizon. That is known as advanced sunrise. Delayed sunset. What is delayed sunset? Actual sunset occurs, then also 2 minutes we are able to see sun above the horizon. That is called delayed sunset. This advanced sunrise and delayed sunset both are due to atmospheric refraction. Let us see the explanation with the diagram. Here the earth is there. Above the earth there is atmosphere. The observer is here, who is on the surface of the earth. This is the horizon. Now actually the sun is below the horizon. Actually the sun is below the horizon. When the sunlight enters the atmosphere, as we know, it bends towards normal. It bends towards normal. Due to that, it appears as if the light is coming from apparent position of the sun. Though the sun is actually below the horizon, but it appears as if the sun is above the horizon. Appear. So that position is called apparent position of sun. So advanced sunrise occur. And same happens at the time of delayed sunset. Advanced sunrise occur 2 minutes before actual sunrise. And 2 minutes after sunset. That is delayed sunset. That means in all we are getting 4 minutes. The length of day increases 4 minutes every day. Scattering of light. As you know, the earth is surrounded by its atmosphere, and the atmosphere of earth is a heterogeneous mixture of different particles like molecules of air, then dust particles, or the small droplets of water, or smoke, or different gases. So here we can say it is a mixture of particles. When the sunlight enters in the atmosphere, it strikes on these particles, and these particles redirect the light in all directions. Or you can say these particles reflect diffusely this light, and due to that the light reaches to our eyes and we are able to see the rays of light. This is known as scattering of light. Tyndall effect. Tyndall effect is a phenomenon of scattering of light by colloidal particles. The Tyndall effect, we can give one example. If a room is closed, it is dark, but you can see the path of ray of light through the small opening or small hole of the window. Here, the light gets scattered due to dust particles. The color of the scattered light depends on the size of the particles. If the size of the particles is much smaller, then they scatter shorter wavelengths. If it is somewhat larger, then they scatter larger wavelengths. When the size of particles, if size of particles is smaller than wavelength of light, then intensity of scattered light is inversely proportional to fourth power of wavelength of light. Fourth power of wavelength of light. And due to this, we are having different phenomenon like blue color of the sky or reddening of the sun at sunrise, sunset. Blue color of clear sky. That means clear sky appears blue to us. Why? What is the reason? When the air particles or the particles which are present in the atmosphere are smaller than the wavelength of light, then the scattered light, intensity of scattered light is inversely proportional to fourth power of the wavelength. The sunlight consists of different colors: red, rosy blue, red, orange, yellow, green, blue, indigo, violet. Red is having largest wavelength. And violet is having smallest wavelength. The wavelength goes on decreasing from red to violet. As you see here, red is having highest wavelength, so scattering of red light will be very less. The violet color is having less wavelength, so its scattering is more than the blue. Blue also gets scattered more than red. Though the violet scattered light is more, our eyes are more sensitive to blue light. As the blue color light scattered more than other colors, we see the blue color of clear sky. Now, why sky appears dark to passengers flying very high altitudes? As you know, at very high altitudes, there is no atmosphere to scatter the light. So the sky appears dark to the passengers which are flying very high altitudes or very few particles in the atmosphere. Next, danger signal lights are red in color. Why the danger signal lights are red in color? These are all 1 mark questions. As we know, red is having largest wavelength, its scattering is least. Scattering is least means its spreading in the atmosphere is very least, very less. So it can reach very far away distance. That means red color we can see from very far away distance. And that is the reason danger signal lights are red in color. Let us see 2 more reasons. The reddish appearance of sun at the sunrise or sunset. As you see in the diagram, the observer is on the surface of the earth. This is the atmosphere of earth. when the sunrise or sunset is there, the sun is near the horizon. Sun is near the horizon. So the sunlight which is coming from the sun has to pass a larger distance and thick layers of the atmosphere. Due to that, most of the shorter wavelengths get scattered away, and only the red light, which is least scattered, it reaches to the observer. And due to that, the sun appears reddish at sunrise and sunset. Second reason, at noon sun appears white. Again you see the diagram. During noon time, the sun is at overhead. Sun is at overhead. And here the sun is near horizon. So the sunlight has to pass a less distance. It is somewhat nearby to the observer. So only blue, violet, they scattered away, and that is the reason remaining they get combined and sun appears white. Second reason, at noon sun appears white. At noon the sun is at overhead. So the sunlight has to travel smaller distance as compared when the sun is near the horizon. So only little of violet and blue color gets scattered, and that is the reason the sun appears white at noon time.